What does it really mean for an AI to think? Today, we're diving deep into the new stack for AI software engineering. It establishes the emergence of a new engineering stack for AI-driven applications and its strategic urgency. The new stack for AI software engineering AI has transitioned from experimental to mission critical. Applications now rely on reasoning, generation, and autonomous action. The stack that delivered the cloud source control, CI/CD, container orchestration fails when behavior is probabilistic. Prompt drift, model regression, and agentic loops demand new abstractions. This stack redefines software engineering around models, prompts, tools, evaluation, and guardrails. It is the foundation for the next generation of intelligent software. It treats AI behavior as a first-class engineering concern, not an afterthought. But here's where it gets interesting. Why the deterministic stack breaks. Identifies the core limitation. Traditional software engineering toolchains cannot handle non-deterministic AI components. Why the deterministic stack breaks traditional software engineering assumes stable, repeatable logic. Code is versioned, tests assert exact outputs, and deployments are binary. AI systems operate on statistical inference, context-sensitive prompts, and third-party model endpoints. A prompt change can silently degrade quality. Model updates introduce non-deterministic regressions. Agent chains fail in ways no unit test can catch. The existing toolchain lacks primitives for prompt versioning, evaluation, or behavioral observability. This is not a gap, it's a category error. A new stack must treat AI as a fundamental shift, not an incremental change. So what's the real problem? Let's talk about AI software engineering is more than code. It reveals the root cause. AI behavior arises from artifacts, models, prompt, context, outside the scope of traditional version control and CI. AI software engineering is more than code. The code-centric worldview treats AI as an API call. But AI behavior is shaped by model architecture, training data, prompt engineering, retrieval context, and tool definitions. None of these artifacts live in Git. No CI pipeline validates them. This leads to fragile, unmaintainable systems where changes cascade unpredictably. The root cause is a mismatch between the engineering toolchain and the nature of AI components. We must expand the scope of software engineering to encompass these new artifacts. The stack must version, test, and deploy AI artifacts like code. This raises a critical question. The AI native stack emerges. Introduces the breakthrough, a stack that treats models, prompts, and agents as first class, integrating evaluation and observability directly. The AI native stack emerges. A new architecture treats models, prompts, and agents as first-class engineering primitives. It integrates evaluation, observability, and guardrails directly into the development lifecycle. This is not MLOps for software. It's a foundational rethinking. Prompt templates are versioned and reviewed like code. Model selection becomes an architectural decision. Agents are composed, tested, and deployed with clear contracts. Evaluation pipelines run continuously, measuring accuracy, safety, and alignment. The stack enables reliable AI systems at scale. It bridges the gap between research prototypes and production-grade AI software. This is the stack that turns AI from a capability into an engineering discipline. Now let's zoom in on stack architecture. Layers of responsibility. Presents the layered system architecture from foundation models up through deployment and monitoring. Stack architecture, layers of responsibility foundation models, versioned, swappable reasoning engines accessed via unified API. Tools and APIs, typed interfaces connecting models to internal services and data. agent orchestration, stateful execution, planning, memory, and tool routing, evaluation and guardrails, continuous scoring of output quality, safety, and compliance, deployment and observability, canary releases, monitoring, tracing, and cost control. Each layer exposes contracts and emits telemetry. Separation of concerns allows independent evolution. This is the architectural blueprint for AI software. It standardizes the interfaces between reasoning, tool use, and evaluation. It's designed for team-scale development, not solo experimentation. Here's something most people overlook: models and tools. The new compute and I/O details the model and tooling layer, where foundation models become versioned components and APIs form the I/O contract. Models and tools. The new compute and I/O foundation models are the compute layer of AI software. They are selected, fine-tuned, and deployed via model registries. Function calling defines the I/O contract. Tools expose REST, SQL, or custom functions with typed schemas. Prompt templates are managed like code branched, reviewed, A/B tested. RAG pipelines index proprietary knowledge with chunking strategies and retrieval scoring. It transforms model integration from ad hoc API calls to managed infrastructure. Models become interchangeable components. Tools become the stable API surface. This layer establishes the foundation for agentic behavior. Model evaluation metrics are tracked per version to detect regressions. Think about this for a second. Agents, the new application logic, describes the agent orchestration layer, where reasoning, memory, and tools combine into autonomous, observable workflows. Agents, the new application logic agents, combine reasoning, memory, and tool execution into autonomous workflows. The orchestration layer manages planning, error recovery, context window limits, and multi-step state. Agent behavior is defined by policies, allowed tools, retry strategies, fallback models. Composing agents is like composing microservices, but with new challenges: infinite loops, hallucinated actions, cost spikes. The stack introduces agent observability, decision traces, action logs, and loop detection. Deploying an agent becomes as routine as deploying a container. Agent workflows are versioned and can be rolled back independently. This layer is where deterministic engineering meets probabilistic reasoning. And this is where things get complex. Evaluation, the new testing framework, explains the evaluation and observability layer, where probabilistic testing and continuous scoring replace binary pass-fail. Evaluation, the new testing framework testing AI systems requires measuring quality, not asserting truth. Eval suite score outputs on accuracy, relevance, safety, and style. Metrics include BLU, Rouge, human preference scores, and custom rubrics. Continuous evaluation runs in CI/CD, blocking regressions. Observability extends beyond logs to trace model reasoning, tool calls, and prompt response pairs. Dashboards visualize drift, cost, and failure modes. This transforms AI from a black box to an auditable system. Reliability engineering becomes behavioral engineering. Teams ship AI features with confidence backed by data. This feedback loop enables continuous improvement of model behavior. But here's where it gets interesting: deploying AI. From chaos to control. Covers the deployment and operations layer, where prompt versions, models, and guardrails are managed with canary and shadow techniques. Deploying AI, from chaos to control deployment pipelines manage prompt versions, model weights, and agent configurations as a single unit. Canary and shadow deployments test behavior against live traffic without user impact. Feature flags toggle models and strategies. Guardrails enforce safety policies at runtime, blocking harmful outputs, detecting PII. Cost monitoring tracks token usage per request. Operations shifts from is it up to is it behaving correctly. This operational model is essential for trust at scale. It brings software engineering rigor to the probabilistic world of AI. Deployments become safe, repeatable, and observable. Progressive delivery patterns adapt to model behavior. So, what's the real problem? Let's talk about the AI development loop. It illustrates the continuous plan, build, evaluate, deploy, monitor workflow that shortens iteration and embeds evaluation everywhere. The AI development loop, the workflow, is a continuous cycle: plan, build, evaluate, deploy, monitor. Unlike traditional linear pipelines, evaluation is embedded at every stage. Prompt changes trigger automated eval runs. Model updates are canary tested with live evaluation. Monitoring feeds back into the next plan cycle. This tight feedback loop compresses iteration from weeks to hours. It enables teams to rapidly align AI behavior with user needs. The loop is the heart of AI engineering velocity. Each stage emits artifacts: prompt versions, eval scores, deployment records. This cycle formalizes AI development into a repeatable process. Feedback-driven development replaces requirement-driven. This raises a critical question: engineering roles transformed. It shows how the new stack reshapes engineering roles, reviews, and reliability practices around AI native concerns. Engineering roles transformed, the AI stack reshapes responsibilities. Developers become AI system designers, composing prompts and agents. Review processes shift from code correctness to behavioral alignment. Quality engineering expands to include LLM evaluation and adversarial testing. Site reliability engineering now covers model performance, cost, and safety. The full-stack engineer must understand model selection, retrieval, and guardrails. This is a new discipline: AI software engineering. Teams adopt new rituals: prompt review, eval gating, and agent debriefs. The career path shifts from code-centric to AI system-centric. The AI stack demands new hiring profiles and career paths. The transformation is organizational, not just technical. Now, let's zoom in on the self-building stack. Projects the future: autonomous agents designing agents, self-optimizing pipelines, and the stack as the foundation for software that writes software. The self-building stack agents will design, test, and deploy other agents. Self-optimizing pipelines will tune prompts, select models, and adjust retrieval strategies automatically. The stack evolves toward autonomous software creation, where human engineers set objectives and constraints. The role becomes goal definition and safety oversight. This future is built on the primitives defined today. The new stack is not just for building AI, it's for building software that builds itself. The foundation is being laid now. Autonomous agents will manage complexity beyond human scale. The stack becomes the platform for recursive self-improvement. The stack is a living architecture.